Give someone 3 months to finish a project, and they'll finish in 3 months. Give a different person 3 weeks to do the same project, and somehow they also finish. Were they 10 times more productive? Almost never. The work just grew to fill the container it was given. But here's the part that nobody talks about. This doesn't only happen with time, it happens with almost everything: budgets, staff, meetings, storage space, software, closets, governments, entire empires. And once you see the pattern, you'll start seeing it everywhere, including in your own life. Today, we're going deep on one of the most powerful governing principles in existence: Parkinson's Law. Most people have heard the famous quote. Most people think that's the whole idea. It isn't. The quote is just the surface. What's underneath it is something far stranger and far more useful: a pattern that shows up in biology, in history, in your phone, and in the way civilizations eventually fall. And I'll save the most surprising version of this law for the end, because it's the one that almost nobody connects to their own daily life, even though it's probably affecting you right now. Let's start at the beginning. Parkinson's Law began as a satirical essay by the naval historian C. Northcote Parkinson, published in The Economist in 1955. Parkinson was a relatively obscure academic before this essay, a British historian and author whose satiric observation that work expands to fill the time available for its completion would eventually make him famous worldwide. He based his comments about bureaucracy on his experiences as a British Army staff officer during World War II, where he watched up close how large organizations behave when you give them room to breathe. The essay actually contains two core findings. The first, work expands to fill available time, is what Parkinson called a commonplace observation. The bulk of the essay discusses the second, that the number of workers in public administration tends to grow regardless of the amount of work to be done. His proof was almost embarrassingly clear. He pointed to the growth in size of both the British Admiralty and the Colonial Office, even as the number of ships and colonies they were responsible for were actively declining. Think about that. Britain was losing its empire. Fewer colonies to manage, less work to do. And yet, the Colonial Office staff rose from 10 officials in 1856 to 372 by 1926, despite a relative decline in colonial responsibilities. He showed that the Colonial Office actually had its greatest number of staff at the very point it was folded into the Foreign Office, because there were no colonies left to administer. He explained this growth through two forces. Officials want to multiply subordinates, not rivals, and officials make work for each other. Parkinson demonstrated that there need be little or no relationship between the work to be done and the size of the staff to which it may be assigned. That's a wild sentence. Read it again. The amount of work doesn't determine the size of the organization. The size of the organization determines the amount of work, because people will always find ways to fill the time and resources they've been given. And this is where it gets interesting, because Parkinson wasn't just describing bureaucracy. He was describing something much older than government departments. Nature figured this out billions of years before Parkinson did. Trees grow until they hit the canopy and run out of light. Roots spread until they hit rock or compete with other roots. Bacteria in a petri dish multiply until they've consumed every available nutrient. Ant colonies expand until food becomes the limiting factor. Predator populations rise until prey populations drop. The pattern is everywhere in the natural world. Life fills the container it's given, and it keeps filling until something pushes back. Cancer cells are Parkinson's Law, without a constraint. They expand without limit, consume every available resource, and eventually destroy the very system that was sustaining them. That's not a metaphor, that's the literal biological mechanism, and it's worth keeping in mind because we're going to see that exact same dynamic play out in companies, governments, and software before this video is over. Ecosystems don't survive because they have unlimited resources. They survive because they have the right constraints. Predators keep prey populations in check. Competition keeps any single species from consuming everything. Remove a constraint from an ecosystem, and the whole thing destabilizes. The constraint isn't the enemy of the system, it's what makes the system work. So why do we keep trying to remove constraints from human systems? Here's where most people recognize themselves for the first time. Think about the last time you had a college assignment due in 2 weeks. How much of that 2 weeks did you actually use? Now, think about a time you had 48 hours to do something similar. You probably got it done. Maybe it was even better because the constraint forced you to make decisions instead of endlessly refining. Hofstadter's law captures a related version of this. Any task takes longer than expected, even when you account for Hofstadter's law. But Parkinson's insight goes further. It's not just that we underestimate time, it's that we actively consume whatever time we're given, because perceived abundance changes behavior. When you have 3 months, the project feels like a 3 month project. When you have 3 weeks, it becomes a 3 week project. The scope doesn't change because you learned something. It changes because the container changed. You see this in house projects that get started 6 months before they need to be done and somehow finish the week before the deadline. You see it in tax returns. Most people file in April, not because they couldn't have filed in February, but because April is the container. You see it in packing for a vacation. Give yourself 2 hours to pack, you pack efficiently. Give yourself a whole day, and somehow you're still deciding which shoes to bring at hour 3. Wedding planning is one of the most dramatic examples. Give a couple 12 months to plan a wedding, and the planning will consume 12 months. Give them 3 months, and they'll plan a wedding in 3 months. And statistically, it'll cost less too because there's less time to add things. The deadline doesn't just create urgency, it creates clarity. And clarity is what most of us are actually missing. Now, this is where Parkinson's Law really starts to scale. Because what's true for individuals is true for organizations, just with more money and more people involved. Every department in every company operates on this principle. Marketing will spend whatever budget it's given. IT will fill whatever server capacity it's allocated. Sales teams will request more features, more tools, more CRM integrations, not necessarily because they need them, but because the budget exists and the space is there. Organizations have uncontrolled growth due to their self-serving nature, with each department creating work for another. And here's the mechanism. Administrators make work for each other so that they can multiply the number of their subordinates and enhance their prestige. This is why meetings expand. A 1-hour meeting slot will almost always take 1 hour, even if the actual decisions could have been made in 20 minutes. A 2-hour meeting will take 2 hours. The agenda expands to fill the time. Email expands to fill the inbox. Reports expand to fill the template. Hiring expands to fill the headcount budget. And the bigger the company gets, the stronger this force becomes because there are more people creating work for each other, more layers of approval, more coordination required, and more time spent on the process of managing the process. IBM, in its peak bureaucratic era, famously required so many layers of sign-off on decisions that the people closest to the actual problem had almost no authority to solve it. Kodak had thousands of employees dedicated to film at the exact moment digital photography was making film obsolete, and the organization kept growing even as the core business was disappearing. General Electric, at its most bloated, had so many management layers that executives reportedly didn't know what half their divisions actually did. In 1986, when a politician complained about swelling bureaucracy in Italy, Mikhail Gorbachev reportedly responded that Parkinson's Law works everywhere. He wasn't wrong. And I want to pause here because this is the part of the video I promised you at the start, the version of Parkinson's Law that most people never connect to their own daily experience. We'll get there. But first, let's look at the place where this pattern is most visible and most absurd. Software. You are carrying a device in your pocket right now that has more computing power than what NASA used to put humans on the moon. Your laptop is thousands of times faster than computers from 30 years ago. And yet, does your computer feel thousands of times faster than a computer from 30 years ago? Does it feel faster at all? Wirth's law, proposed by computer scientist Niklaus Wirth, states that software is getting slower more rapidly than hardware becomes faster. Wirth himself drew an analogy directly to Parkinson's Law, adapted as software expands to fill the available memory, illustrating how every efficiency gain in hardware just creates room for more software complexity to move in. Software bloat is the process whereby successive versions of a program become perceptibly slower, use more memory disk space or processing power than the previous version, while making only dubious, user-perceptible improvements. Think about Microsoft Word. The version from 1997 could do almost everything most people need a word processor to do. The current version is orders of magnitude larger in file size, uses far more RAM, and for most users, the experience of just typing a sentence hasn't meaningfully improved. One analysis found that despite massive gains in computational performance between 2000 and 2007, Office 2007 performed the same task at half the speed on a 2007 computer as Office 2000 did on a 2000 computer. Electron apps, which are applications built on web browser technology, are one of the most visible examples of this. Slack, Discord, Visual Studio Code, Spotify's desktop app, these are all essentially websites running inside a browser wrapped in an application shell. They use hundreds of megabytes of RAM to do things that native apps could do with a fraction of the resources. And the reason they exist this way isn't because it's better for users, it's because it's faster and cheaper to build. The resource abundance made the bloat acceptable. Modern websites work the same way. A website from 1990 might have been 50 kilobytes. A typical news article page today, with all its trackers and scripts and frameworks, can be 5 to 10 megabytes, 100 times larger, to deliver the same basic thing: words on a screen. This parallels what's known as the Jevons paradox. Hardware efficiency gains don't lead to leaner software. Instead, they enable more resource-intensive applications that consume the additional capacity. As hardware improves, software expands to exploit it fully. And here's the uncomfortable question about AI. Right now, the promise is that AI will make us dramatically more productive. And in many cases, it will. But will companies get smaller as a result? Will we work less? History suggests a different outcome. If AI allows you to answer 30 emails a day, and suddenly you can handle 300, guess what happens to email volume? It rises to 300. The expectation adjusts to match the capacity. Every productivity gain creates a new baseline, and the new baseline immediately becomes the floor, not the ceiling. This is exactly how Parkinson's Law has always worked. The efficiency doesn't reduce the workload. It redefines what the workload is supposed to be. And this connects directly to Goodhart's Law, which we've covered on this channel before. When a measure becomes a target, it ceases to be a good measure. The moment you optimize for a number, the number starts to game you back. But let's bring this closer to home, because one of the clearest, most personal demonstrations of this law is something almost everyone has experienced. Your house. You move into a bigger place. You tell yourself you finally have enough space. And within a year, the new space is full. You buy a bigger garage, and the garage fills. You rent a storage unit because your house is full, and the storage unit fills. You get a bigger closet, and somehow, within months, the closet is full. The space didn't create organization. It created permission to accumulate more. The container expanded, and the contents expanded to match it. Minimalism, at its core, is a direct application of Parkinson's Law in reverse. By constraining the container, fewer shelves, fewer drawers, a smaller home, you constrain the accumulation. The limit is the design. And this isn't just about physical stuff. It's about attention, time, and money too. Because money is another container. Parkinson later devised a second law. Expenditure rises to meet income, which he detailed in a follow-up book. And this one might be even more personally relevant than the original. Income doubles, and lifestyle doubles with it. A raise doesn't create savings. It creates new spending categories that didn't exist before the raise. This is lifestyle inflation, and it's one of the most well-documented patterns in personal finance. Studies on lottery winners consistently show that a large percentage end up in financial trouble within a few years, not because they were irresponsible, but because the container expanded dramatically and their spending expanded to fill it. Hollywood movies demonstrate this at scale. Give a studio a $30 million budget, and they'll make a $30 million movie. Give them $300 million and they'll make a $300 million movie. And the $300 million movie isn't necessarily 10 times better. The money gets absorbed. Government budgets work the same way. Military procurement programs routinely run over budget, not because of corruption alone, but because the money exists and the systems expand to use it. College tuition has risen at a rate that outpaces inflation for decades, partly because the availability of student loans expanded the container, and costs filled it. Healthcare costs follow a similar pattern. The resource doesn't constrain the spending finds the resource. And now, the version of this I promised you at the beginning. History's largest organizations, empires, are Parkinson's Law operating at civilizational scale. The Roman Empire at its peak required an administration so vast that managing the administration became the primary activity of the empire. Supply chains grew, bureaucracy grew, the military grew, paperwork grew, complexity grew, and eventually the cost of maintaining the system exceeded the value the system produced. Parkinson noted that the total employed in a bureaucracy rose by 5 to 7% per year, irrespective of any variation in the amount of work to be done. Multiply that across decades, across an empire, and you get a system that collapses under its own weight. The British Empire followed the same arc, the Ottoman Empire, the Soviet Union. In every case, the administrative apparatus kept growing long after the productive capacity of the empire had peaked. The Colonial Office, Parkinson's original example, had its largest staff when there were almost no colonies left to manage. The pattern doesn't care about the scale. It works the same way at the level of a government department and at the level of a civilization. And this is the thing that makes Parkinson's Law genuinely important, not just interesting. It's not a productivity tip. It's a governing principle. Nature fills containers. Companies fill budgets. Governments fill tax revenue. Software fills hard drives. People fill closets. Meetings fill calendars. The force is constant. What varies is whether or not there's something pushing back. So what does pushing back actually look like? Here are 10 ways to use this principle directly. Cut your deadlines in half. Not for everything, but for the next project you're working on, try giving yourself half the time you'd normally allocate. You'll be surprised what actually gets done when the container shrinks. Reduce the available budget before you start. If you give a project team $100,000, they'll find $100,000 worth of things to spend it on. Give them $60,000 and watch what they prioritize. Limit meetings to 20 minutes by default. A meeting with a 20-minute slot will almost always resolve faster than a meeting with an hour. Set the container, and the conversation fills it. Own fewer possessions. This sounds simple, but the mechanism is real. Fewer shelves means less stuff. The constraint is the design. Delete software you don't use. Every app on your phone is a container for your attention. Fewer containers means less time spent filling them. Keep empty space on your calendar deliberately. A full calendar isn't a productive calendar. It's a calendar where Parkinson's Law has already won. Protect empty time the way you protect important meetings. Use one-page reports. If a report can only be one page, the writer has to decide what actually matters. That decision is the most valuable part of the process. Create artificial scarcity. Constraints you impose intentionally are more powerful than constraints imposed on you. A writer who gives themselves 1 hour to draft something will produce more than a writer who gives themselves a day. Add constraints before you add resources. The instinct when something isn't working is to add more people, more money, more time. The question worth asking first is whether the problem is actually a lack of resources or a lack of limits. And the 10th one, the one that ties everything together, is simply this. Ask yourself regularly whether the system you're in is filling a container or doing something meaningful. Because those two things can look identical from the inside, right up until they don't. If you've made it this far and this kind of thinking resonates with you, the idea that the best business and productivity principles are really just universal patterns showing up in different forms, then this channel is exactly where you should be. Drop a comment below with a place in your own life where you can most clearly see Parkinson's Law at work. I read every single one, and the answers are always more interesting than I expect. And if you want to go deeper on the related idea of how measuring something changes the thing you're measuring, the video on Goodhart's Law is right there waiting for you. Here's the core of what we covered today. Work expands to fill the time available for its completion, and the number of workers in any organization tends to grow regardless of the actual amount of work to be done. But that's just the beginning. The same force operates on budgets, on software, on physical space, on income, and on empires. Every system expands to fill its container until something constrains it. The constraint isn't the problem, it's the solution. Software requires more computational resources with each new release, reducing the performance gains provided by new hardware. And that's Parkinson's Law in code. Empires collapse under administrative weight, and that's Parkinson's Law in history. Your closet fills up the week after you clean it out, and that's Parkinson's Law in your home. The most efficient systems aren't the ones with the most resources. They're the ones with the right limits. And the moment you understand that, you stop asking, how do I get more? And start asking the more powerful question, what constraint would actually solve this? That's the whole idea.